Yes, Kirtana, you can start now.
Yes, sir. Just when the caterpillar thought the world is ending, it turned into a butterfly. Good evening to one and all. I, Kirtana, member of IEEE APS Society, take the utmost pleasure of welcoming you all to Day 2 workshop on Introduction to Machine Learning. It's my pleasure to welcome our beloved Chairman, Dr. B. Babu Manoharan, sir, Managing Director, Mrs. B. Jessipriya, ma'am, Director, Mr. Sashi Sekhar, sir, our Principal, Dr. P. Ravichandran, sir, who give us the constant motivation for organizing this workshop, and a very hearty welcome to today's speaker, Mr. S. Kamalesh. Before moving on to the session, a few instructions to the participants. If you have any queries, kindly post it in the chat box, which will be modified to the speaker by the end of this session. The feedback link will be posted by the end of the session. Now, I'd like to share a few words about today's speaker. Mr. Kamalesh has more than 3 years of experience as a data scientist, machine learning, and deep learning. He has a sound knowledge in scikit-learn, Keras, TensorFlow, NLP, and Flask. He has worked on numerous projects and has conducted several workshops. I now invite Mr. Kamalesh to kindly begin the session.
Yes, thank you. Thank you for the nice introduction. And first of all, good evening to one and all. So, as we seen the last day, like what some basics, right? Some introduction, some basics, those things and all. But today we are going to move on with technically. Okay, so just wait a minute. With technically. Okay, so in today's session we are going to see about machine learning, supervised learning, and classification. Okay, in so actually we discussed it in previous session, like machine learning have three type: classification, sorry, supervised learning, unsupervised learning, and reinforcement learning. So today we are going to see about supervised learning, and in supervised learning also we have divided into two type. One is classification type and regression type. So we are going to see in today's session classification type. Okay, so for this today's session we need a data set. Okay, so for this today's session we need data set. The data set available in the Google Drive link, okay, which I sent in our chat box. Those who are not downloaded the data set, plus please download the data set, so which I sent in our chat box. Again, I am sending to you. Okay, so please click that link. After clicking that link, it will be enter into an this Google Drive link. Okay, so here you have to download the dataset Indian liver patient.csv. Okay, so this is the dataset we are going to use in today's session. So please download it. Just click right click and then you will be have a download option. So download it. And after downloading, you just keep within your PC. I will tell you, you have to import this dataset, which you are download dataset will be, you have to import to your Google Colab. Okay, so I will tell you. So in yesterday itself, I will tell you how you need to download the, sorry, how you need to open the Google Colab. Okay, so just enter into the Google search engine and type Google Colab, and then click the first link, and then after clicking the first link it will be enter into the next page. The next page is called as a welcome to collaboratory. Okay, so here you can create a new notebook file. Okay, so after you creating the new notebook file, you will be getting like this only. Okay, so that's it. Okay, you have to run this under we seen yesterday itself. Okay, so now I'm going to tell you some basic thing. Okay, so we are using some data set, and we know in machine learning we have supervised learning, classification type, but working procedure of classification type till now we don't know. So I will tell you first working procedure of classification type, and after that I will tell you what is the data content. Okay, and first we have to analyze the data set, and after that we'll enter into the technical session. Okay, so the webinar is two part. One is analyzing the data set, then what is classification. After that we will be move on to the technical part. Okay, So first I will show you the data set which I downloaded using that link. Okay, so download Indian liver patient. So this is the data set I downloaded in my using that link. I downloaded this data set. Okay, so here we have a data set of liver patient. Okay, so whether the patient will be attacked by liver disease or not. Okay, here I'm having age, gender, and total bilirubin and direct bilirubin. Like that, we are having some attributes. It's based upon the liver patient checkup details. Okay, so here I'm having some details. So first we have a gender column and the age column, and then we'll be have some other attributes, and at last we are having a data set. Okay, so just I am seeing this data set, I can't understand what is this exactly it's representing, right? So we know we need to predict whether the patient will be have a liver disease or not, but we don't know what is this data set contain, right? So for that purpose, I open my Kaggle website. Okay, so here only I downloaded the data set. Even this link also I will update in our chat box. You can just check it out. So here, this is the dataset link. Okay, so which I sent in our chat box. So here we will read about the dataset first of all. So this dataset contained 416 liver patient records. 416 liver patient record. How much? Like, okay, so 416 liver patient record. Total I am having 584. Total count I am having 584. In this 416 liver patient and then 167 non-liver patient records. Okay, so total we are having this 584. Okay, so and then records will be collected from the northeast of Andhra Pradesh, India. Then dataset column, we are having a column name dataset. Yes, here having dataset column, and is a class label used to divide the group into liver patient or not a liver patient. That is liver, the person who attacked by liver disease and no disease. Okay, so the data set contains 441 male patient record and 142 female patient records. Okay, so here we are having a data set column representing whether the patient will be attacked by liver disease or not. But here we are having 1 or 2. Okay, 1 or 2. What is this 1 or 2 represent? So okay, so here we will check it. Okay, better you can go with this analysis. Okay, so here already they mentioned 461 liver patient records, right? So 461 liver patient record means if I filter my data set here 416. So here 1 representing the patient attacked by liver disease, 2 representing the patient not attacked by liver disease. Okay, so 416, as I said here, 416 liver patient record. So here in our data set, 1 is attacked by liver disease and 2, the column which having is not attacked by liver disease. Okay, so this is the data set we are going to use in this today's webinar. So those who are not downloaded, please download the data set. I send a 2 link. One is Kaggle website link. Another one is my Google Drive link. So please download it. Just keep with it. I will tell you how to import the data set to your Google Colab. Okay. So this is the data set we are going to use. So, okay, so let me enter into the session. What is classification? How we need to use this classification type of algorithm in machine learning. Okay, so for that purpose, I'm going to use Paint. So as I said before, we are having a data set, right? We are having a data set. So now the data set contains some futures and some output column, both the dependent value and independent value. So I need to tell you one thing here. The column from age to this column will be called as a, generally they will called as a here. So up to this, okay. So this from age to here, they will called as a independent column. Okay, independent column is nothing but the data. Okay, so the data of the each and every patient. Okay, so that is generally called as an independent column. Then we are having here output, right? So this is output column, right? One means patient attacked by liver disease, two means the patient not attacked by liver disease. That is called dependent column. Okay, so you have to understand about this what is independent and what is dependent. That is important. Okay, so if you have a both independent and dependent column, it comes under supervised learning. In your dataset, if you have a dataset with independent and dependent column, it comes under supervised learning. And if you see the dependent column, okay, you will be have a output prediction like 1 or 2, yes or no. So as I said last day, that is yesterday, classification algorithm means we need to predict yes or no or low, high, medium, like that, like this classification type, right? So if you need to predict an output like that, means we need to use classification type of algorithm. Okay, so logistic regression or SVM, support vector classification, or any other algorithms. Okay, so here I am taking the data set. After you are taking the data set, now we analyzed the data set, right? So we analyzed the data set, what is the data set contain and what is the thing we need to do. Here you can see my data set having some categorical column also. Okay, so not one thing, guys. If you want to train machine learning or deep learning algorithm, any model, okay, so during training time, your data want to understand by that algorithm. Okay, any algorithm, that's not a problem. If you are giving any data to train the algorithm, okay, the algorithm want to understand your data. Okay, suppose if your data have like this, for example, here you can see I'm having categorical column. So if your data set having any numerical column, it's easily understand and easily train. We can easily train the algorithm. But if your data set in the text format or like this format, categorical format, means you need to convert those categorical into a numerical. Okay, so here we have one problem. Okay, we need to convert this informations. Okay, so that's what we need to do. So that's what we need to analyze in the first step. Okay, so just we need to analyze the data set. After analyzing the data set, you need to move on to the next step. Okay, so second step is nothing but you need to like you need to do some process. Okay, for example, generally they were called as a feature engineering. Okay, feature engineering. So what you have to do, you have to plot some graph. Okay, exploratory data analysis, or you have to check whether you are having any missing value available in your data set or not. Okay, handling a missing values, or you need to check whether your data having outliers or not. Outlier is nothing but, for example, here you can see 1, 2, 3, 4, like this. I am having data. Okay, 1, 2, 3, 4, 1, 2, 3, 4, like that. But sometimes you will be have data like this 100, means this is called as outliers. Okay, so normally your column data will be like this format only, but suddenly you will be have some incorrect data, or you will be have like this some unimportant data. Okay, so that is called outliers. You need to check whether your data having outliers or not. Okay, or you need to do some categorical encoding. So for example, in our data set, we are having a gender column. In gender column, we are having two types like male and female. Okay, you need to convert this male and female like 0 or 1 or 1 or 0, any type. Okay, so you need to convert your data like this. So that is categorical encoding. And you need to do some process like normalization or standardization, those things and all. Okay, so that is called feature engineering. After we are applying the future engineering, we need to move on the next step. The next step is third step. Third step is nothing but like you need to do some future selections. Okay, you need to do future selection. Future selection is nothing but like correlation. You need to check correlation means nothing but you have to compare your each and every attribute with one another. Okay, for example, age will be compared to gender, this total bilirubin and direct bilirubin, like that. Okay, so you are comparing your each and every data within these attributes. So that is called correlation. Okay, why we are comparing means we need to take some important data, important attributes in your data set. So that is the use of data correlation. And we are having like backward estimation, those things and all. Okay, so even though we need to do some univariate selections, those things and all, that is called, that and all comes under in future selection. After that future selection, we need to move on to the next step. The next step is nothing but fourth step is dividing your data set into two types. Okay, so one is trained data set and another one is test data set. Okay, so train is nothing but, for example, if you are taking an 1,000 data set, 1,000 data in your data set, for example, I am telling 1,000 data are available in your data set. Okay, so I will divide this data into a two type. One is train and another one is test. Okay, so always train should be an higher amount. Why? Because we need to train the algorithm. Okay, algorithm wants to understand what type of data you are giving and what type of prediction want to give. Okay, so that's why we are giving like 700 and 300 of data to the test. That is, we randomly we are dividing the data into train and testing. Okay, so for this purpose and all, we are having some packages, inbuilt packages. We are using those packages only. Okay, so generally for this purpose we need to use a sklearn package or scikit-learn package. The package, about this package I already told you in yesterday's class. Okay, so we are using those packages and we are dividing the data set into two type. One is train and test. After dividing this, we are going to train the algorithm, train the model. For example, I'm using logistic regression. Okay, so using logistic regression, I'm going to train the model. Okay, and after training the model, I am going to give this test data to the algorithm. Okay, I'm going to give this test data to the algorithm. Algorithm will be give the prediction result, who are all attacked by liver disease, who are all attacked by non-liver disease. Okay, for this 300 data, algorithm will be give the 300 output result. Okay, so those output result will be compared with original result. Okay, actual result and prediction result. That and all I will tell you in detail after at the technical part. Okay, so this is the thing we are going to do in classification. So the training the algorithm and testing the algorithm is very easy thing, but doing the first to fourth step or third step is somewhat difficult. Okay, so first step also easy only, but second and third is somewhat difficult one. Okay, so I hope everybody will download the data set. The dataset name I already told you, Indian liver patient.csv file. So please download the dataset using that link. After downloading the dataset, you can update me in our chat box, Zoom chat box. It's downloaded like that. So I'll be move on to the technical session. Okay. Up to this, anybody have any doubt? Even though you can ask now itself using chat box, I will explain you. Why? Because machine learning, like if you are understand the coding, or if you're understanding the basics thing from the starting onwards only, you will be comes to understand some other fourth step and fifth steps and all. Okay, so if you are lagging with the first step and second step, means you can't understand the fourth and fifth step. So whatever you are doubt having, just send a message in between chat box. Okay, if I see the message, means definitely I will give the information regarding about your doubt. Okay, So this is what classification. And today's session, I just give the overall view, okay, how you can do the classification algorithm, okay. But I'm not doing something like best accuracy result or something hyperparameter tuning, those things and all, okay. So you are the beginner, okay. So just I will show you how you can train the algorithm and how you can predict an output result and all, okay. So even though if you want to improve the accuracy result or if you need to predict an exact output result, you need to do even though some other few things and all, few things, okay, apart from what I'm teaching, okay. So just I am showing as a like demo, okay. So I'm opening my Google Colab, okay. So after you downloading the dataset, which here you can see, this is the dataset I downloaded now, okay. I'm going to import the dataset to my Google Colab. If you want to import your dataset to Google Colab, means you have to click first left side of files option, okay. In left side you are having a files option, just click the files option. If you are not getting this three icon, okay, uploading, refresh and drive, Google Drive, if you are not getting this icon, just click here connect, okay. So you will be have an option, or just wait for a few minutes, you will be automatically get this three icons. So here you have to use the first one, okay. So here you can see Indian liver patient and open it, okay. So the dataset which you are importing, that will be deleted after you close this tab, okay. So that is after runtime, okay, it won't recycle. So just your notebook file will be saved in your notebook file will be saved in your Google Drive link, but this one will not save. This is recyclable, okay. That is automatically it will be deleted in your Google Colab, okay. So here I'm having a data set Indian liver patient.csv. Then I opened my Google Colab, so everything is fine. I am going to start the class, okay. So technical part. So before that, I need to import some basic packages. The package name, I already told you some shortcut keys yesterday, right? So shift plus enter, don't forget, shift plus enter means you can run the cell, okay? So instead of clicking this icon, you can use shift plus enter means automatically you can run the cell, and control plus space, okay. So this is for to get a suggestion from your Google Colab, okay. So just memorize about this, it will be helpful for you for easy typing. So now I'm going to import some package like import numpy. Anything font problem means you just update me on chat box, I will rectify it. This font size is enough, I need to increase the font size, just update me on our chat box. Import matplotlib as import matplotlib pyplot as plt, and then import cbon as sns, import cbon as sns, then import pandas as pd, okay. So this is the basic packages, it's enough, okay. I will tell you in between what are the packages you have to import for pre-processing or future extraction and all, okay. So this is the package you have to run. First of all, after typing this few lines of code, don't forget to run this cell, okay. Shift plus enter. So now you can see I run the cell, okay. The every packages in which I used here will be imported to the name for this, okay. NumPy will be, whenever I need NumPy, I will use NP. Whenever I need pandas, I will use PD. Okay. So now I need to read my data set which I uploaded in our Google Colab. Okay. So this is the data set name. I can easily import by using pandas. Okay. So first I'm going to create a new uh, DF. Okay. So DF is variable name. Then yeah, I have to tell one thing about pandas. Okay, so pandas totally having like 1D type, 2D type, and 3D type. Okay, so 1D is nothing but it's a series type. Okay, so your data will be in the form of series. That is called 1D. 2D is nothing but generally they will call as a data frame. Okay, so data frame which I'm going to data frame type only I'm going to read. Okay, so this is the data frame. It will be normally what is the frame? It will be contain more number of rows and columns, like okay. So like this is the data frame. Okay, so we are using the data set is data frame, and we will be have even 3D also. Okay, so pandas generally have 1D, 2D, and 3D. So we are using here 2D. 2D is nothing but it's a data frame. So our data set is also in the form of data frame only. Okay, so now using PD, I'm calling the PD. PD is nothing but pandas. PD dot read underscore CSV file. Okay, so this is my CSV file, right? Comma separated value. PD dot read underscore CSV. Then I'm going to, I need to type the name. Okay, Indian underscore liver underscore patient. It's difficult, right? Definitely, I will made a mistake. This many long is that name. So instead of that, you can use shortcut key. I already told you what is the shortcut key for suggestion. Okay, the suggestion shortcut key is control plus space. So I will just type the starting word of my data set like IN. Then if I use control space, automatically I'm getting the suggestion Indian liver patient.csv. So just click it. Okay. So after you done this one, you just run this cell and then create a new code line and then type df dot head. Okay, just run it. You will be get an output result. Normally head is nothing but default value. Default is 5. First 5. First 5 in your data set. It will be displayed first 5 in your data set. That is the use of head function. Okay. If you want, for example, if you want first 4 means you can give in this bracket first 4, or you need only 1. You can give like this also, but default is first 5. Okay, so that is the use of head function. Suppose anybody have any error at this line, okay, you will be have totally 2 type of errors. Definitely in my point of view, the error is first one, PD is not defined. PD is not defined error. If you are getting this error, PD is not defined error, don't you forgot to run the first cell. So please run the first cell. Suppose if you are not getting this error, definitely you will be get this error. That is file not found error. Found error. Okay. So the file not found error is nothing but first you check whether you imported your dataset correctly or not. Okay, Indian liver patient.csv. If you are getting if you are imported correctly also, again you are getting file not found error means just check the spelling of your CSV file. Okay, Indian liver patient.csv. Just check the spelling. Even though you are getting any other error means just copy your error and then paste it in our chat box. I will check it out and update you. What is the thing you have to do to rectify the error. Okay, so definitely you will be get this 2 error. So please check it out. if you are not getting this error, definitely you will be get this output head function. Okay, so head is nothing but it's a default. We can print the first 5, and we have even another one also, the tail function. Tail. Okay, so tail is nothing but print the last 5. So that is the use of this head function. The next thing what I have to do means I'm direct. Okay, so I am creating a new cell. Here I am checking the shape, df dot shape. How many rows and columns available in our data set. So totally we are having a totally we are having 583 sorry 583 data and 11 columns. Okay, so rows and columns. So if you need to check the shape, you can use this shape inbuilt function. You can check it out. Suppose if you need to check the only you need to check the column name means we can use like this df dot column. You can check only the columns names in the data set. Okay, so that is the use of df.column. Then the next thing you have to do, so we checked the df.shape and column and even head also we understood. Okay, then suppose you need to I told you about outlier, right? So suppose you will be have some outlier like this in your data, means you need to rename those outliers by using mean value or median value of your data. Okay, so if you need to check the median value or mean value or standard deviation value, like that means you have to use one of the function. The function name is nothing but df.describe. Okay, so describe is nothing but it's used to find your count. So here you can see overall count value of each and every column, and then mean value of each and every column. Here age, the mean age between from starting to ending. The mean age of starting to ending is 44. Okay, standard deviation value 16, and minimum value, that is lowest age in your age column, is 4, right? Here you can see 4. So I'm also getting 4, and maximum value is 90. So if I check the output here, what is the maximum value? Yes, 90. Okay, so like this you can get some information about your data, that is statistical information. Okay, statistical information of your data set. So that is the use of describe function. Then next you can use some other thing like, suppose if you need to, if you want to drop the duplicates, for example, here we are having 586 rows, right? 586 data. Definitely you will be have some duplicate data, right? So if you need to drop those duplicates, means you can use like df dot drop duplicates. Okay, you can drop the duplicates, and then so using this function you can drop the duplicates, but within this line only it will be applicable. Okay, suppose if you are checking here means if you print the df means it will be definitely have duplicates. Okay, so for rectifying this you can use like this. Okay, df, again I'm save it in same variable name. Okay, after I am removing all the duplicates in my data set, that is in my variable df, then again I'm save it in the variable df. Okay, just I'm overwriting into the same variable name df. Okay, so if you check the shape, print df dot shape, you will be get a 517. So totally before we are getting 583, right? 583 comma 11 Now I am removing some duplicates. Finally, I am getting 570. Okay, that is the use of this df.drop duplicates. Okay, so if you need some information also, here you can see in Google Colab we will be get the informations. What are the parameters are available? Okay, here you can see these are the parameters available in our within that function. Okay, you can use those parameters and you can apply. So that is the use of removing the duplicates. Okay, so now you can not only removing the duplicates, you can check your information. For example, uh, you can check whether your dataset having any null values or not. Suppose if you are having any null values in your dataset, you can't train the algorithm. Okay, so to check the null values, you can use the function name is called as a isNull function. Okay, isNull is the function used to check the null values, but here you can see detect missing values. But you need to, for example, if you are running this null values, you will be get like this false false true true. Totally I'm having 582 columns. Okay, within this 582 columns you need to find where you have true, means it's a difficult one. So for that purpose you can use df dot sum. Okay, you can finalize your whether you are having null values or not by using this sum function. Okay, it will be calculate each and every row column, sorry, each and every column data. So here whenever I am getting any numerical value, so there is any some null values available in your data set. Okay, so here you can see 4 null values are available in this column. In this column, the 4 null values are available. Suppose if you are having a null values, you have two options. Okay, whether you can rename, that is whether you can fill the zeros in your null values or whether you can remove the null values. Okay, for example, here I am going to show you how you can remove the null values. Okay, and I will tell you how you can wait a minute, just here I'm going to use df dot drop na. So if you are using this function drop na function, automatically your data, this null values will be deleted in your function. Okay, so that is the use of drop na. Suppose if you need to fill the null values, means you have to use the function df dot fill na. Okay, using this function, within this function if you are giving a number like 0 or 1, means it will be fill the null values by applying 0. Okay, but here I applied the null values, here I'm dropped the null values. Okay, if I check again whether null value, so now some null values will be dropped here, right? So if I check again, I will be get output yes, here null values are available in your data set. Why I am getting like this means, so we have to do this method. Here I dropped the duplicates and save it in another variable, right? Like same thing you have to do, but instead of that you can do another one also, that is in place equal to true. Instead of using a more number of variables in your programming language, you can use in place equal to true. So it will be automatically overwrite your all the, after dropping the null values, automatically overwrite in your df. Then if you are checking again whether you are having a null values or not, here means it won't give the output. See here, I'm getting here 0. So that is the use of dropping na in place equal to true. You can apply this one for here also. Here, okay, dropping duplicate also you can apply here. So, but I need to tell you two ways, right? So you either you need to use this way or you need to use this way. That is your wish. So that is the use of dropping the null values. So here I dropped my null values. This one we don't need. I'm deleting this column. So next thing, after dropping the null values, you have to check what are the data available in what type of data types. Okay, for example, here I'm having a different columns, right? So in these different columns, I have to find which of the column I need to do some categorical encoding or I need to do some pre-processing. Okay, so for that purpose, df dot info. Info is the function used to find the information of your data set. So here age is integer type, so we don't need to do anything. Gender is the object type. Yes, if you are getting any object type, data type, okay, if you are getting any object type of data type in your information function, you need to convert this object type into an integer or float type. Okay, so then only algorithm will understand your training data. So everything is integer and float type, only one, this one, gender column. Okay, so now I'm going to convert this gender column into an integer column. Okay, so that is the step. First step is called as a feature extraction. Okay, so till now what we have done, this part only. So now only we are entering into the next part, that is feature extraction part. We are going to doing some label encoding method and converting our object type into an integer type. Okay, so now I will show you how you can do those process. Okay, so for that purpose I need some packages. Okay, so that one we will, okay, this one we will do it later. Okay, so before that I will show you some graphs. Okay, that is somewhat interesting, like exploratory data analysis. Okay, I forgot to show that graphs and all, right? So after a graph you will enter into the system. For example, you need to see the histogram. Histogram is nothing but, here you can see it also like histogram only. Here in Kaggle website also you are seeing some graph, right? So this also histogram graph only. Okay, so I will show you how you can plot the histogram. So df dot hist. Okay, and you need to give the like figure size. You need to give the figure size. So figure size, for example, I'm giving here 15, 15. Okay, so this is the figure size, and then I'm giving here x dot. Okay, so what is the use of x dot? Here you can see x dot is nothing but rotation of x-axis label. For example, the values of 19 display the x label and rotated in the 19-degree clockwise. Okay, x dot will be rotated your data in a 19-degree clockwise. That is the use of x dot. Otherwise you can use, or you don't need to use, that is your wish only. Otherwise I will use bins. Okay, bins is used to basically used for how you want. I will show you. Okay, first time giving bins equal to 10, then you just see the output result of this plot dot show. Okay, first I will show the output result for this applying bins equal to 10. What you are getting, you can see. Okay, so this is the graph for each and every attribute I am getting. Here you can see here some data in the form of after 16 we are having. So this and all, suppose it's to be an outliers. Okay, so here continuously we are having, it's not a problem. But here you can see after 600 or 700, I'm getting some, I'm not having any data, but here I'm having some data. So that are all outliers. Okay, so this is generally called a histogram. You can check it out. Okay, so but this one is not outliers. Okay, so here we are having totally 1 and 2 only, whether the person will be attacked by liver disease or not. Okay, so these are not outliers. So some data will be called as outliers. Okay, so that one you have to understand what is the main difference between outliers and these zeros and ones. So like this also you can plot some graphs of each and every attribute. This is generally called as a histogram. So now I am using here bins equal to 10. Suppose if I use here bins equal to like manager changes 30, 13. Okay. See here. So definitely you will be comes to know what is the previous output and now current output. Okay. So previous output is somewhat different. Now current output is somewhat different. That is the use of bins. Okay. So that is the use of histogram. I hope everybody will understood about this histogram. Okay. Generally they will call as a, the function name is hist, but the graph name is histogram. Okay. So this is the one of the graph. And if you need to, even though you can plot the graph, I will name it here. Okay. For your understanding. So I used here even Cbon also, right? We imported Cbon also. Using Cbon, I will plot on graph. That is easy graph. Create a new cell. SNS Cbon dot count plot. It's a easy graph, easy to understand also. Within this count plot, I am going to pass my this column, gender column. Okay, I'm going to pass the gender column. So first I have to give the input. Okay, so what type of input I have to give? Uh, what is the column name? Gender, right? So gender, otherwise, okay, gender, column name gender column. Okay, then yes, I need this, which one? YQ type data. Yes, we have to give data. So the data where I saved my gender column data. So where I saved in the variable name df, right? In the variable name df. So we need to give here data equal to df. Okay, so then after that I am going to run the cell. See here. So this is called count plot. Okay, this is the use of count plot. Here female, how much count? Female like more than like 140, and then male we are having more than 400. Okay, as I seen in our Kaggle website, exactly same output only. 4 1 male and 4 1 4 2 female. Okay, so that is the use of count plot. Suppose if you, this is based on x-axis, right? This is default is x-axis. Suppose if you change like this, y is equal to gender means you will be get an output into an y-axis like this. Okay, so that is the easy graph, easy way you can plot the graph, output graph like this. Okay, so that is the use of count plot. So you can plot whatever it is. If it is a either categorical function or either what is that, numerical function, you can plot a graph easily. So that is the use of this one. Now I am going to show you like, yes, you can easily you can edit the graph for even data set also. That is output column. For this column also you can easily edit. Just to copy the code and paste it here. Then rename this data set and then run it. Okay, so if you need x-axis, you can remove it. You can plot the graph as a x-axis. Okay, suppose you need size, figure size, you need to give figure size means you need to use here like plt dot figure size figure and figure size. Okay, you can plot the graph with figures. Okay, so within this figure size we have two parameter x and y. Okay, you can give the axis like 5,5 anything. Okay, so your graph size will be removed. Actually we need to use matplotlib inline. Here we are getting like this future warnings and this and all. So we need to use here, that is in either in that particular cell, or you need to use whenever you are importing, you need to use matplotlib inline. Okay, so that one I forgot to import, but so that's why I'm getting like this. So that is the use of this one. So now what I have to do means I need to convert my data into an numerical data. That is, we already know which one is object type. So using information function, we comes to know there is a trouble with this gender column. Okay, we need to convert this gender column into an integer or float column. So we need to do those process. So that is called converting your, this generally it's called as a label encoding encoder. Okay, so what I have to do means I need to import one package from sklearn. Okay, using sklearn, I need to do the process, that is label encoding process. So from sklearn dot pre-processing. Okay, so pre-processing, when you hear this name, we enter into like future engineering. Yes, yeah, in we are in future engineering only. In future engineering, these steps will become pre-processing. Okay, sorry, not pre-processing, label encoding and all will be, that is categorical encoding will becomes under future engineering only. Till still we are not enter into this session. We are still here, future engineering. Okay, from sklearn pre-processing, then import label encoder. Actually, we have different way to convert our object into, that is categorical data into a numerical data. Here I am using the one of the way is called as a label encoder. Okay, but we have different way. Okay, so now what I am going to do now means after importing the label encoder, okay, we are going to do here like this. I am saving the function in one object. Okay, the object name is called as a label and LE. LE is the object. I'm saving the function in this LE. Okay, so I'm importing the function, and after that I'm save it in LE. So this is, we will do these steps again and again, even during training time, training the machine learning algorithm also. Okay, so that is the use of label and this step. So just saying saving our label encoder function in LE. Now you have to create a new line, new code, and here you need to apply the method. Okay, so first of all you need to know, you can create, suppose for example here we are having totally how many columns, like these columns are available. Suppose you need to create a new column in your data set, you have to use this name. The name is nothing but df. Okay, def, the variable name, and then new column name. So new encoder gender column, right? Encoding gender column. Okay, so here I'm created the column name encoding gender column, encoder gender column. So this column is not available in our data set. Okay, we are only going to create the column, so that's why I created now. But within this column, I don't have any data. Okay, now only I have to save some data. So I created a new column. Then after this column, I'm going to call my label encoder function using LE. Okay, LE is nothing but this one, right? Using LE, I'm going to call this function, and I'm going to use fit transform. Okay, so fit transform. What is the use of fit transform? Fit label encoder and returns the encoded labels. Okay, fit the label encoder and returns the encoder label. So here I'm going to use fit transform. After using fit transform, I am going to give my dataset name. So which dataset I have to convert this column name. Yes, gender column only I have to convert, right? So I have to give the name of the gender. Here I'm creating gender. Okay, so now I'm calling the label encoder function, and I am transforming my data, which data, object data, into an labeled data, that is zeros and ones, then save it in my new column. Okay, so here I am not defining anything. Male will be a 0 or female will be a 1, like that. Okay, so automatically based upon the weight it will be convert and save it in this new column. Okay, so when I run this cell, I will create automatically the new column name will be created, and then save it in our df. So suppose if I use get function df.head 1, see here, this is my old gender column, right? So when you scroll right side, you will be have a new column name that is called en gender column, that is which I created now only, right? So I created a new gender column, and then I transfer my data to this new gender column into zeros and ones. So here it's mentioning first one is 0, so 0 is nothing but female, so it's converted female. Female is equal to 0, and then male is equal to 1. Okay, so that is the use of this one. And now I converted, so now I am having totally two column. One is converted gender column, another one is categorical gender column. So now you will be comes to know the categorical gender column is we known it, that is not an important one, right? So you can directly remove that column by, okay, so I will tell you how to remove the column. Before that, I need to tell you something about pandas data frame. How can, okay, just wait a minute, I will open the new paint. Okay, so here I have a data set, right? So it's a data set is nothing but it's a data frame, I already mentioned. So how I am telling it's a data frame again and again means if you check the type of your df, you will be get a output pandas core frame data type. Okay, so that's why I am telling here it's a data frame type. So in data frame type, you will be have like axis. Okay, for axis you will be have. So what is this axis? So axis totally we are having two type of axes. One is 0, another one is 1. Okay, so suppose if you want to do something with column wise, okay, so if you want to do something with column wise, you have to use the axis equal to 1. Okay, so here just wait a minute. So like this, we are having a data. Suppose you need to drop this particular column in your data set. You have to use the axis equal to 1. Okay, axis equal to 1. Suppose you need to drop some rows. You need to delete some rows in your data set. You have to use the axis equal to 0. Okay, so this one you have to understood. Okay, so whenever you are playing with data frame, you need to understand this one. So here I need to delete my gender column, right? Whole gender column. So if I need to delete the gender column means I have to do axis equal, I have to give the mention the axis. Okay, so I will show you without mentioning the axis how it's getting an output, with mentioning the axis how we are getting an output. Okay, I will show you. So now I'm going to use like df dot drop. Drop is nothing but to delete the. So here I am asking labels. So I have to give the label name gender. Okay, gender. So here I'm gender. Okay, then I'm going to mention the axis, wrong axis. Axis I'm giving as a wrong one. For example, I'm giving here, actually we need to give the axis 1, but I'm giving here 0. So if I execute this line, I'm getting an error, key error. Okay, so here gender not found in a axis. So I already told you here I'm using the axis 0. So what is the 0 represent here? 0 is based upon like column wise, sorry, row wise. Okay, so 0 is whenever you want to do anything, you have to row wise, you have to use axis equal to 0. But here in my row, I don't have any name starting with gender. I have a name starting with index value only. Okay, 0, 1, 2, 3, 4, 5, 6. So if you are giving here instead of this, for example, instead of this gender, if you are giving here 0 means, okay, definitely we will be get a output result like this. That is 0th index value will be deleted and we are getting only starting with 1. Okay, so previously we are having a 0th index value. Here you can see 0th index value, but now I am getting here 1. So that is the use of axis equal to 0. Okay, so now I need to drop the gender column. So here I am using axis equal to 1. Then I am executing this line. So here you can see there is no gender column, but I am having the encoding gender column. So that is the use of this drop column. So don't forget to use new variable df equal to like this, or instead of this you can use the parameter in-place equal to true. In-place equal to, okay, so that is the use of this one, in-place equal to true. So I hope this and all definitely understand by you guys. Okay, so anything up to now, anybody have any doubt, you may ask using your comment box. Okay, so I will explain you definitely. So this is the thing. Okay, so df dot drop you have to use and to delete the columns, those things and all. Okay, the next thing I done everything. Suppose if you need to check the correlation of each and every attribute, you can use easily like this df dot correlation CORR. Then if you execute this line, you can get the correlation of, see here, age, total bilirubin and total. So what is the use of this correlation means you can comes to know what are the data we need to take and what are the important attributes and what are the data we need to take to train the algorithm, those things and all. So that is the use of correlation. Even though this correlation we can even though this correlation we can see it in graphical way also, there is graph way also. Okay, so the generally they will call as a heat map. Okay, so I will show you the within this one in within heat map here using SNS same Seaborn only, Seaborn heat map, and then df dot correlation. Okay, so what I am typed here, the same thing only here also, but I use the Seaborn heat map function. Okay, what is the heat map? After I am running this cell, you will be comes to know. Just wait a minute. So this is generally called as a heat map. Okay, so heat map is nothing but generally if whenever you are ready to learn about heat map, you have to see either it's a diagonal, right? This diagonal, we have a diagonal, right? So this is always zero only. Okay, so you have to see either upper side or lower side, but two sides are equal only. Okay, what you are having here, the same color also available here only. Okay, so two sides are equal color and equal lead splitter. You have to analyze either it's a downside or either it's a upward side. Okay, so how you can analyze this heat map? Okay, heat map by using this right corner. Right corner we are having one panel, right? So 0.2 means 20 percentage, 4 means 40 percentage, 6 means 60 percentage, 8 80 percentage, and 100 percentage. So whenever you are having some color intensity light color, okay, so that is the most important features in your data set. Okay, for example, here in this data set we are having a most light color is like, I think here we are having, okay, that is total proteinous and albumin. So the comparatively these two are somewhat important data. Okay, so like this you need to analyze your heat map by applying like this. Okay, so heat map generally mainly used for checking the important score values, important attributes in your futures. Okay, so that is the use of heat map. So you can plot like this also, you can plot like this also. So that is our wish only. So that is the use of heat map. Okay, so now, yeah, everything exploratory data analysis and label encoding, everything we done, right? So we done probably most of the future engineering step according to our paint. So future engineering, okay, we done a lot in future engineering step. Now only we are enter into the future selection. Yeah, future selection also we done the correlation, right? Now only we draw seen some correlation and then univariate selection, those things and all. Okay, so this is the thing you need to do whenever you are going to train the machine learning algorithm. You definitely want to do those steps and all. Okay, so future engineering and future selections and all. So now everything is done. Okay, I'm going to divide my data set into like I already told you in in this data set we are having a independent column and dependent column, right? So I'm going to save my independent column and dependent column in separate variable. Okay, so that is the use of. So here I'm taking a two variable x and y. Okay, so in x, independent independent is nothing but what is that? Data. Only data will be available in this x. Okay, next one, dependent. Dependent is label, or also called as the output of your data will be saved in y. Okay, so here I'm going to take some particular data. Okay, so df x and y. I'm using x equal to df dot I location. Okay, I location. So what is the use of I log means? You just see the information. Okay, it's loading. Just after within between this, we will type. After this, here you can see. ilog is nothing but it's a purely integer location based indexing for selection of by a position. Okay, so purely integer location based indexing. So that is the use of ilog. Here I am going to take every rows in my data set. Okay, totally we have two type of parameters. The first one representing every rows in your data set. The next one is representing this data will be called as a selecting the particular column. Okay, first one is this is from starting to ending every rows. Here starting to ending every columns, but here I am giving some condition. What is that condition is df dot column, the column. Okay, that is in data in df variable the column name which not equal to data set. Okay, I think you will be understand data set is my output column label name, right? So without this data set column, I need to save all my data into X variable. So the same code, just copy it here. Here you need to use equal to data set. Okay, so when I execute this line and I'm creating a new code, x dot head. So in x dot head, I'm getting an output result like this, but without data, without label, output label. So if I print y, you will be comes to know what we are done here. See here, data set 1, 1. That is the use of this one. Okay, so y dot head and x dot head. So we saved our data separately x and y, that is independent and dependent separate. So that is the use of this x and y. Okay, so now up until we enter into the session, like up to this we done x comma y we done. So we have to divide our data set into two type, train data and test data. Till now we are done this one, but up to this we finish it, right? Okay, so y dot head and x dot y, everything we finished. Yeah, so up to this it's fine. Okay, so tomorrow we will start freshly how to train the machine learning algorithm, how to divide our data set into two type, those things and all. Okay, so if we have some few steps only. Okay, so the time is 7:25. So tomorrow we'll start freshly how to train and how to test the machine learning algorithm. After that I will enter into the deep learning algorithms, how we can deploy the deep learning model using Keras and TensorFlow. Okay, so up to this, anybody have any doubt, you may ask.
So we have few questions from the participants.
I am not audible.
Sir, am I audible?
Somewhat louder, ma'am. I didn't hear your voice.
Am I audible, sir?
No, ma'am. Just wait a minute. Volume also 9. Yes, ma'am.
Am I audible now?
Somewhat.
Is it okay now, sir?
Now it's fine.
Okay, sir. The first question is, how do you handle missing or corrupted data in a data set?
Yeah, here we use function name. This one now, df dot drop na. Okay, so using this function, we are going to check whether we are having any null values or not. Okay, so this is the parameter to check whether we are null value. It's a inbuilt packages. Okay, in Python mostly we are using some inbuilt package only. So here you can see if we are getting null values, you can drop the null values. So previously I'm checking whether we are having a null values in our data set or not by using isNull function. Okay, so this is the one of the inbuilt function. Using this function, I'm going to check whether we are having null values or not, missing values or not. So here I'm having a 4 missing values. Okay, so missing values can replace in two way. One way is like filling the values. Another one way is replacing the values. So here I done a replacing, okay, by using drop NA function. If you need to fill the values, you can fill by using fill NA function.
Thank you, sir. So I have posted a code in the chat box, sir. So
Okay.
the question is, what is the column name for x-axis and y-axis in the graph while using this code, following code, which I posted in the chat box now.
df.hist figure size. Actually, this is x-axis. This is general, like general configuration of your graph. For example, if you plot any graph within, if you're here, you can see I posted this one. Yeah, this is the graph. Here, I have it already data in my variable df. Then I'm using a histogram graph. So that's why I'm calling hist function. Then I am mentioning here my figure size should be an 15, 15. That is each and every attribute figure size will be a 15, 15. Then I'm giving here bins equal to 13. That is size of each spike in your graph. That is the use of this bins. So in this, what is your exact question, ma'am?
Sir?
Your exact question, what you asked?
What is the column name for x-axis and y-axis in the graph while using that code?
This is default. Okay, whenever you are giving an input, that's why here I used df. I directly used the data and I plotted the graph. So here x-axis will be represent the, for example, it's a age, right? So in age 0 to 18, 0 to 18 is nothing but from age values, that is 0 to 18 values, that is x-axis. X-axis will be a age and y-axis will be a number of counts. Okay, so totally I'm having nearly 15. Age will be a nearly 14 counts. Y-axis is the count.
Okay, sir. That's all. We have questions, sir. So
Okay,
thank you for the wonderful and informative session.
okay, ma'am. But till we are not finished in machine learning, we just enter into the like which is the part fourth step. We are not entered into the fourth step. Tomorrow we will start the class as soon as possible and we will finish the machine learning part. Then we will enter into the deep learning part. Okay.
Okay, sir. On behalf of the IEEE Societies of Electronics and Communication Engineering, St. Joseph Institute of Technology, St. Joseph Group of Institutions, and the entire fraternity of the institution, first of all, extend my most sincere thanks to the Almighty for making today's event a resounding success. I extend a hearty thanks to Mr. Kamalesh for this extremely useful session, and my heartfelt thanks to our beloved Chairman, Sir, Dr. B. Babu Manoharan, for his consistent upkeep in conducting this workshop. My sincere thanks to our Managing Director, Ma'am, Mrs. B. Jessie Priya, and our Director, Sir, Mr. Sashi Sekhar, for their guidance in conducting this workshop. I also thank our Head of Department, Dr. C. Nyana Kausalya Ma'am, Staff and Student Affairs, Dr. G. Rohini Ma'am, Lab Affairs, and all the other faculties for organizing this event successfully. This workshop will be continued tomorrow on Keras Fundamentals for Deep Learning. Stay indoors, sanitize, and stay safe. Thank you.